So what I've got here is a scan of the Mamba flight controller. This is an MK4 Mark IV 722, and they call it the app because it has the Wi-Fi built in. And what we need to wire in are multiple things. Obviously the motors go to the ESC, but the ESC also talks to the flight controller. So what we need to do is allocate connections for things like the DJI video system and receiver as well. So down here, they actually give you a set of default ports. So we're going to use, another one. We're going to use UART1 for the receiver. Yep. We're going to use UART3 for the DJI. It says VTX, that's going to be the DJI. And the receiver is going to be ELRS. Telemetry, this one down here, that's our ESCs. And that what we get back from the telemetry is things like rotation speed of the motors, and that's used in the filtering of a quadcopter to give a better result. We've already got Wi-Fi on UART4, so we can't use that. And what we're going to do is use, I think, UART2. UART1 is here. That is for our receiver. That's the ELRS. VTX is down here, but it's actually also available on the plug-in port underneath, so we'll use the plug-in rather than soldering that one. Oh yeah, that's the DJI. So those are the connections we're going to make. Everything else is done. So under here, if you look here, it says S8 to S5 and S1 to S4. These are the connections for the ESC, but again we've got a socket underneath, so what we're going to use is the ESC socket. That'll just be a wired plug that they supply with the flight controller. So there's only one we've got to end up soldering to the flight controller, and that's the receiver onto these 4 pins here, 5-volt ground, RX and TX. And remember, when you're doing a UART, you have the RX, and you have the TX, and the TX. I'll just put this. I'll use this as a receiver. So you actually wire the RX to the TX and the TX to the RX. That way the transmission, which is the T, goes to the receiver, which is the R. So in all cases when you're wiring up, remember UARTs here, RX, TX, TX, RX, they always oppose each other. And this is the ESC. The ESC looks much simpler because it is really, it's 4 times ESC. So if you imagine an ESC has 3 motor connections, basically that's 1/4, and it's repeated 4 times. You put your power into one side, and as it says down here, because we're doing 6S, it wants the capacitor connected, and I'm going to be using these little wires here and here to connect the capacitor. Just makes life a little bit easier. The connection is a plug at this end and a plug at the flight controller end. You just got to make certain, and it's really really important, I can't stress, that you get these wires in the right order. You don't want these crossing, so double and triple check that your connections match up. So you got current TX. Notice there's no RX here, it's just a TX. That's because these sort of ESCs only transmit data. They don't listen. You can't talk back to them that way. They listen in for signals in on these, and they transmit out the data from the motors, but they don't give you any more. They also do give you a current sensing line, which so the flight controller knows how much power you're pulling, and they also supply the power needed to run the flight controller through the ground and 5 volts there. And it tells you when you're setting it up, when you're setting up your Betaflight, what the scaling is for the amperage, so that makes sense to the current sensing. So 1/10 of a millivolt per amp. It tells you you can use 300 or 600 D shots, and this is running BL Heli S, but I'm going to be updating it to Blue Jay, BLU. I'm not sure if it's got the E, but Blue Jay, and that's a open source software that actually provides virtually the same signaling and computational strength as BJ Heli 32. So you get all the bidirectionality from it that you don't really get out of Mamba. So this is going to be, I'm going to be running D shots bidirectional. So I'll get data in that way about rotations. This is a really confusing overview of connections to remotes, but the important ones to look at here are the plug on the bottom that goes to the DJI. On the air unit there's a plug. On the Vista, wires to solder to the Vista. Okay, so this is where I'm at the next stage of the electronics. I've replaced these bolts, which were supplied at 20 millimeters. I've replaced them with 25 millimeter M3s and a small standoff spacer. I think that's probably 5 millimeter. And the reason I've done that is there's a problem I see quite a lot with putting DJI Vistas on frames, is if I put the 4-in-1 ESC down and then I put the, so I should put that the other way, put the Calyx Vista on first, that will fit there, just dangle that there. So there's the 4 bolts that fit the Vista, and there's the 4-in-1 ESC. They're already very close to each other. And then on top of that, I've got a wire, big old wires, you know, for the power battery. I've got to wire that, so that makes it even more awkward. Then on top of that, because I'm running 6S, the ESC says I've got to run this capacitor across here to reduce noise, and it just becomes a logjam. It's just absolutely awful. Everything's crammed into between here and here. So my solution for that is to run the ESC backwards. That way, the only thing that's getting in the way of each other is this connector here. This connector here, which leads to the flight controller and sends the signals to and from the ESC, and this cable here. And by using the 5 millimeter standoffs, I deconflict those two connectors, so that now sits quite happily. I've set up the longer connector between, I'll come back out, the longer connector between the ESC and the flight controller, and that will just fit like that backwards into the flight controller. Works great. Downsides of this is absolutely fine, because if you look on the I'm forgetting the name of it, the Armattan, they do a version of this that they build, and they run this with the ESC in the normal way, and they literally run the power cable underneath the ESC to run it up here. I'll have a much shorter cable running between there, and I can just come up through this hole here. So that works absolutely great for connecting the battery. So that's all good. The downside of doing this, and it's not as big a downside as it used to be, the downside is that these ESCs are marked. I don't know if it's going to show up on the camera. I'll try and get it on the camera. They're literally marked 1, 2, 3 and 4, and that corresponds with the 4 expected motor positions that Betaflight is expecting, the software that it runs. Because I've got this on backwards, 1 is going to be where 4 is, and they're all going to be all over the place. So the 1 says here, but it's actually going to be here, and vice versa. It's going to be wrong. But Betaflight 4.3 has an easy way of remapping the motors so the motors go to the right outputs. Previously to that, you had to actually go into the control and type commands to change the mappings, which was an absolute pain. This way it's a lot easier. So that's what I've decided. I'm going to run the ESC backwards, run the flight controller on top. The flight controller will be the right direction, that makes life easier. You see the little arrow just here? Normally you always go with the arrows, that way everything default just works. But on this one I'm going with the arrow this way for the flight controller. The ESC will plug into the socket underneath the flight controller just there. This can actually run 8 motors, this flight controller, hence the 2 sockets. So that's the plan. Next I'm going to put all the wiring on as per the diagram I've gone over with you, and I'll show you the soldering of that. Other things to note is I've replaced the standard module at the back of the frame with a modified version that I bought on eBay. Yeah. So this would normally fit in there. So the modified version is actually a crossfire antenna receiver, antenna holder, holds it really nicely, and I prefer the aerial for the DJI to be more vertical, so that's the replacement there. And on the front I've got a connector here that's going to go, that part there will go round the front frame and bolt down, provide a nice solid mounting for any HD camera I might want to put on. The problem is I'm not running crossfire. This is a crossfire receiver, and it's pretty small. It's got long range, but it uses 898 megahertz in the UK, 900 in the States, and the aerials are quite big and huge, whereas the ELRS I'm using is 2.4 megahertz. And look at the size of the aerial in comparison. I'm still going to use this, but I need to modify it. And what I've chosen to do is to take in a couple of these little gummy things you use to mount used to mount flight controllers. It reduces vibration. You put them over and these take some of the vibration out, makes for cleaner flying. But what I'm going to do is put these in the sockets here, and that will support that aerial, and I'll show you that now. I'll show you how that's going to work. So take that out. Going to put these into there, one in that side, one in that side, and they fit really nice there. Then the ELIS receiver, which is even smaller than the Crossfire one, that antenna will go into that rubber grommet, and this one will go into that rubber grommet, and the whole bit just clicks together like that. Now, because the rubber and the TPU are effectively transparent to radio waves, that's not 100% true, but almost transparent. That shouldn't make any difference to the receiver, but it gives lots of lovely protection to the aerial out the back of the when it goes on the back of the quad. So that's what that is. That's what I'm going to do there. So let's do some wiring. It's super mega close-up time now, as you get a close-up on here and I use my funky magnifying glasses to see what I'm seeing. Nice hot soldering iron, and I'm just going to tin the ends of these wires. Now, though these look quite short, they still ain't short enough most of the time, because what you're going to wire these to are these connectors here, and as you can see, they're very, very stubby. So I'm also going to put a little bit of solder on each of these. The one near the EP1 with the other pad here, that's the ground. This is the power. Oh, sorry, no, yeah, ground and power. Then TX, which transmits to the RX on the flight controller, and RX, which listens to TX from the flight controller. So they talk to each other through them. Now, if you look, if I hold this wire up to here, it's longer than that. So what you want to do, get my nippers, you want to try and cut your wires to match the size of the pad. And these are really small pads, so I'm just going to trim a teeny bit off that one. That looks better. You don't want too much hanging over, because it's a chance for shorts and it's a chance for more wear. I'm going to put some heat shrink over this after anyway to help protect it. So I'm just trimming these wires. The power to and from the electrical voltages are very small. Right, I'm actually going to turn this around like this. Because I'm right-handed, I like to work soldering hand in the right, so I'm going to hold the wire up from this side and just dab the soldering iron. Because they're both tinned up, they'll connect almost instantly. So I've just got to make certain I get them in the right order. So the extra pads nearby indicate that's the ground one. And I'm going to use the convention of black for ground. And you want to try and hold it there just for a moment to make certain it doesn't move as the solder solidifies. So that's ground, power. Now for TX, I'm going to use green. Why not? It doesn't matter. Oops, didn't hold it there long enough. That's better. It doesn't matter because if it doesn't work one way, it will work the other way, so you just swap them over. Just as long as you don't try and power it through the TX and RX. So there we are, ground, power, TX, RX. And I'll put a little bit of double-sided tape on the bottom on the heat shrink to stick it down inside the quadcopter to stop it bouncing around. And there we go. One heat shrunk receiver ready to go in. It gives it some protection. Okay, the next thing to wire up is the Cadex Vista. Now, unlike the air unit, which is illustrated here, the Cadex Vista doesn't have a plug in the back. Instead, it has solder-on connections, and they are from this side, and you can see there's a touch of solder already on this, which means Cadex actually tested this before they sent it out. So we have V for voltage, G for ground, RX, TX, another ground, and S-bus. Now the S-bus and this S-bus and ground is if you're going to use the radio control through the Cadex Vista. I'm not going to. I'm going to use the LRS. I like to separate my control signal from my video signal so there's not a single point of failure. And on the flight controller, these two end ones, the black and the yellow, that's the S-bus signal and the ground. So we've got from the Cadex to the Cadex, from the flight controller, we've got ground and power, the red one, and we've got TX and RX, the red and the white and the yellow one. So what I'm going to do is I'm going to remove these two wires here. Just going to snip them off since I'm not using them. And if you snip a wire off from a cable connector, snip it really short. That way there's no chance of it shorting out, you know, the ends of it getting anywhere. So I've got to look at this wire. Power and ground, that's easy. Power and ground, that's easy. But what have I got? I've got next one on this diagram is TX. That's a yellow is TX, that's important to know, and white is RX. So the next thing is to just judge the length you're going to need for this. So here's the flight controller plugged in. Sorry, this is all really close up work, so it's quite difficult to display. And this I'm going to run underneath, and the Vista unit, I want the plug the USB this side so I can change, update software, etc. This is the aerial connection for the Vista, and these are the four wires to connect up to the flight controller. So I'm going to run them under the Vista and then up to the flight control, up to the Vista there. So that's going to be the cable run. So I don't need quite as long as the cables they've supplied. I'm going to cut them a little bit shorter, give myself a little bit of wiggle room there. And now doing exactly the same as I did with the transmitter, with the receiver. Take off the ends. The nice thing about a silicone wire is you can just use your nail pull off the outer shield. It comes off real easy. Get them straight. Little twist to keep the bundles of wire all together. Bit of the old blue tack. Stick them down into that. And it's tinning time. Soldering time. Clean the solder. Always use a clean soldering iron. I always use one of these copper things to clean the tip of the soldering iron. Copper coils. And again, because these connectors are very short, I want very short ends of wires. So I'm just going to trim these up a little bit. Keep them down to around about 2 or 3 millimeters long. Right, and then we can solder the ends of this plug to here. I'll deplug it after. So I'm going to come up this way from underneath. So I want to solder the wires into the base here. Again, the old blue tack comes in handy. I can just put that at an angle. Take the instructions out of the way. Try and get you to see that. And I'm just going to tin up the Vista. Remember, this Vista is quite expensive compared to a lot of the other components, so you want to be quick about it. So that's the power. That's the ground. TX and RX. Not going to do the last two. So let's solder these on. Can you see that? Yes, you can. Power. Ground. I'm worried now that power is actually going to touch the aerial shield, so I'm going to lower that a little bit. There we are. Ground. So the next one is RX, and I want TX from the flight controller, and TX is the next one along, which is the yellow one. Yellow one's next. So you just have to make certain you get the right orders. Again, if you get it wrong, you can always swap the wires on the Vista. You can just unsolder them and swap them over. But it's better to get it right first time, don't you think? And then the receiver, RX. Yep, I don't like that one. The reason I don't like that one is because the wire's too long. So I'm just going to trim that down just a little bit more. A little bit more fresh solder on the connector, and we'll be good. Much nicer. I'll just have a look at that. Disconnect the cable from the flight controller end, and then have a look down here. Don't know if you can see that. Let's zoom in. You can see that's a nice neat job there. Cool. That's the cabling done for the Calyx Vista as well. So we've done the receiver and the Calyx Vista. This is the top deck. that, or I think it's that way. Yeah, that way. And this cable coming through here. So I don't want that length, I want it shorter than that. But how much shorter? I think about that length. So I'm going to lose a bit off the top here. Oh, these are always harder to cut because they are, as I said, quite chunky. Whenever you're soldering or connecting up, it's important not to make cables too long, and it's important to keep connections, as the bare metal connections, as short as possible. So this is going to go from those connectors that way round. That's the positive, it's marked. That will go through the top here, and you're always talking to yourself about it. You see a problem? I cannot get that through there. So if I go through there, I'm going to have this stuck on it all the time. Is that a bad thing? I've got to decide now. Doing quadcopters is all about choice, making the right decisions. If I run it through here, I might actually end up knocking against the battery. So I'm going to come up through here, knocking against the camera support, because the camera part fits here. Yeah, so that's going to cover that. So I'm going to come up through that hole, which is fine. So if I run that like that, positive. Now I've got to have the capacitor on as well. And if you get a capacitor like this, you need to know which is the positive and negative side. Some capacitors have a line or a stripe down one side indicating the negative. If it's a capacitor supplied like this, there's a stripe on the top, and that side, the wire that corresponds with that stripe, is the negative. So you want to make certain that goes on the negative side. And this one actually supplies little holes either side. You can put them into the main connector points, or you can take it a little bit wider and go through these points here. Choice. I think I'm going to solder this wire and then use the outside points. So next thing, solder that wire onto there. Take it off the frame. See, they've got notches here. You can either solder your wire like that to it, like that. But since I'm doing the wire straight up, I'm going to use the wire into those notches, and that will give me a neater solder connection. These ESCs have a lot of metal, a lot of weight to them. They're quite heavy for their size, so they take a lot of heat to solder to. You'll be amazed how much solder the wire will soak up just in itself. So you want to get a good helping of solder on these connectors. I can already tell you this must be the earth one, because it's sucking the heat away a lot quicker than the positive. So I reckon that's the earth one. Let's see if I'm right when I turn it over. Oh, it is. Look, yeah, it's marked on that side. The earth is connected to the ground plane inside the ESC, and as such it will wick heat away from your soldering iron really quickly, whereas the positive side is only connected to the positive sides of each of the chips, so there's a lot less metal. You can see the difference. That's setting off real quick. That's taking its time to set off. Okay, so I've already soldered there, and I'm going to put a little bit of solder just in these little bits as well, just to make sure they're soldered in there. Okay, and you just want to get to the point where this solder flows into the wire. Don't be afraid just to keep feeding it. And we'll do that side as well. And just when you think it looks great, flip it over and you'll see it hasn't gone anywhere on the other side. Most of the time you end up having to do both sides. And it really does suck up the solder big time. The bubbles you're seeing is actually the flux. Yeah, and then I've flipped it over. Just make certain I've got it on both sides, so both sides are full of solder. I'm going to do the negative first because that's the most difficult to get to flow. And you're looking for a nice smooth join between all the solder, so I'm heating the wire up, get that all nice and flowing, and when that's good and hot I'm going to put it up against the negative terminal and just hold it there as long as my fingers will take it, pretty much until I know that solder's co-joined. I don't have a dry joint, what's called a dry joint, which is a bad joint, so I'll just hold that there. I'll be looking at it after. See, look, that came straight off. That was a bad joint, even though it was hurting my fingers. So at this point I'm going to use tweezers to keep heat away from my fingers. So that's not taking the heat properly. So at this point you want to, if you have a temperature controlled iron, you want to let's have a look at blue tack. See how it's got that hot, the blue tack has become one with the ESC. We'll let that cool off. That will come off once it's cool. I'm just going to have a real close look here. Oh look, you can see that joint. That joint is a dry joint. That joint is a good joint. There's a big difference. And my objective is to make that joint look as good as that joint. So let's try that again. See if now the iron's heated up a bit, I might be able to get this to work. Come on. It's getting there. There we go. Now I'm testing it by putting some more soldering and see if it sticks or as it flows. And it's flowing on the wire. This is such a high power ESC. Right, I think that's done it. If you look at those joints now, the joints look far stronger. No movement. Ow! Still very hot. can't feel any movement there or there. That's good. Double check, have I put them on the right way round? Yes, of course I have, but it's always worth checking. Not the prettiest of solder joints, but it's effective. Right, okay. The hard bit's done. All the other joints are a doddle in comparison, she says. Whenever you do any soldering, you're looking for good neat soldering, good flow, and that is not good flow actually. That's better. It's getting better anyway. Okay, that's pretty good, and I think I might just solder on the top as well, just to make sure we got really good joints here. See, that is a bad joint. See, it's blobbing up, it's not tenting. That's better. Again, it's the negative side. It just wicks so much heat out, it's difficult to get really good joints with a medium to low power soldering iron like I have. Okay, that's enough soldering for the moment. I think I've done, apart from the connecting the motors up. Tidy this up with a little clip, nice and close. That will do. Negative is on the negative, negative on the negative, positive to positive. Cable's done. Okay, that's the ESC done. So here we are. We have the ESC, the flight controller, connected via this cable here. We have the DJI transmitter connected by this cable here, and the camera, which is running via cable underneath through to the DJI. Now the next stage is either attach the receiver for the radio control, or attach the aerial for the transmitter of the video to the DJI. But because once you attach them, they're flopping around the place. That's actually not the bit. I don't think that's the best thing to do next. I think the best thing to do next is to bolt on these lovely motors here and solder them up to the pads, and then use the cut-offs we get, because we're only cutting these cables down to this length. All this can go between here and the relative pads on the ESC, and I'll probably take the flight controller off. No, I'll leave it on. It's easy. The pads are easy to get to. So the first thing to do with all this is, I think, to tin, is put solder on all these pads on the motor side, and I'll tin the other side as well. So let's get on with that. Oh yeah, definitely hot now. Again, you just want to see good adhesion of the solder to the pad. So I'll do all 6 pads. That looks nice. Next one. long as you know a little bit about soldering and a little bit about wiring connections, it's really not that difficult. The difficult choices are in choosing what to put on and arranging the position so it makes sense. Right, next thing, I'm going to bolt these all these motors to the ends here. I won't bore you with that, so I'll see you after I've done that. So there's all 4 motors connected. They're just 4 screws on the bottom of each one. It's nice that the manufacturer gives you a sort of Loctite compound on the end of the screw, so you don't need to do the dipping in the blue stuff. I've got the name right. Now, an important thing, and I'm just going to zoom in here as much as I can, is if you look at that screw there, it goes into the base of the obviously into the base of the motor, but you see it doesn't protrude out the top, not a bit. And that's how you really want it to be about the same, the screw to be long enough to go through the arm and have some good meat into the base of the motor, but not to go up any further than the motor if possible, because most modern quadcopter motors are open based. So if your screw went up into those windings, it would short them and it would destroy the motor. So I'll just do one of these as well. Let's take all the other wires out of the way, neaten up the place. So the way these are done, and I've seen them where these sort of extenders have 3 pads in a row, and they're quite, you know, on a narrow arm like this, that's quite a constraint to try and solder. So by staggering the 3 makes life a lot easier. So what I'm going to do is just cut this to the length of this side, you know, the far side of this, and that'll be the middle one. Then the other 2 I'll cut to the far side of that, and we're just going to take off that much length of the insulation to solder down. So check my soldering irons on, it still is. I'm going to cut this, I don't know if you can see, just going to judge that by these are edge cutters, so they cut on that side. So I'm going to judge that to the length of that. This is where you hope you don't cut wrong, so that's going to go fine in the middle. Then the other 2, take that out of the way, I'm going to judge for that one, and the far side one, judge for that one. Oh, nearly cut the middle one there. Right, so that's the motors cut to length, the motor wires cut to length, and we're going to keep them really neat and try and keep them flat. Not only does it look nice, but it will just oh gosh, that's difficult to remove. Usually this sort of stuff you can take off, so that's fine for that. Again, it's silicone wire, so it comes off quite easily, but being a bit thicker, this doesn't come off your fingernails. I just tried it. It's just a bit too thick to do with your fingernails. So you've got to be careful with the nippers not to come in too tight and actually cut the wire inside. So there's the motor wires, and I'm just going to give them a little twist. And as ever, we're going to tin these up with some solder first. They're stiff enough to hold up, we don't need to use blue tack or anything like that. So out with a handy soldering iron and solder, and just when you're looking at this, it's good to look nice and close to make certain you don't have any like whiskers of wire sticking up, because you do not want shorts across these wires. That would cause problems. I have a stopping the motor running most likely, but equally if you left your power on a short, it will destroy the ESC. We don't want that. So now I'm just going to offer it up, and that can be nipped off a little bit in length. And again, it's all about making certain these wires, the exposed wire, is as small as possible. Right, and then I'm going to use my tweezers just to solder these into place. Yeah, that looks nice. And because they're both tinned, it really is just a matter of holding them together, and they should connect quite nicely. Doesn't matter if it flares a little bit, because of the staggered nature of this wire connector, you're not going to short easily to the other side. But you do want them sort of angled down. It's just fiddly, like most of the small wiring like this. Just a bit fiddly. That one I am not happy with, and it did not. It hasn't got enough solder on it. That's better. The more you solder, the more you know how to recognise a good joint and a bad joint. Yep, that looks fine. I still don't like that one that much. I think I'm going to put a little bit more solder on that and just push that down again. Not the most beautiful joint, but it's solid and it's a good joint. And I'm going to do the same for that all the way around. But remember, keep your other wiring, because that's going to go between here and and the 3 connectors on the ESC. Just here to here, middle one, far end to far end. And I'm going to do that all around. But first I'll do the motors. Do these motors first, like that. And we're very close to finishing this. So this is the result. All the motors attached to the arms and attached to their connectors. That makes for very neat arms. The next bit I'm going to do is I'm going to tin all 12 of these connections. So I'll do a couple, but I definitely will cut out a lot of this, because it's really boring watching someone solder. I've taken off the flight controller for the moment. I did decide that it was better access was good access. But again, it's like right when I was soldering this on, the ESCs always have they sink a lot of heat, so you really have to sort of take your time. So I'm just going to solder these on at an angle like this. 1, 2, 3. Okay. Solder at this end. That's not gone on. And again, you're looking for a really nice flow of solder. I don't know if you can see that. It looks pretty nice there and good and solid. So we'll just do that for the other 3 going this way.
2. You can imagine now we've got all 12 wires attached. It's just a case of judging the length, cutting them to length and soldering on at the other end. Try and keep these as neat as possible, and if you can, try and angle them in a little bit just to keep them out of the way of the blades. So I'm going to go for something like that on this side, and it's just a case of just cutting to the longest one and then cutting the other two to fit the other part of the connector and soldering them up. And you do want to keep this as neat as possible. What I tend to do after that is I have some sticky back cloth tape, and I'll wrap that around here just to hold these down even more. It's all about making it look good, keeping the wires neat and tidy, and that's what I'm going to be doing now. Just cutting and soldering these, just like we did with the motor end to these things. And take your time, make it neat, and you can see the result of my wiring. If you do make a mistake, I made one of these way too short. There's plenty of spare, so you can do it again like I did, and you end up with a nice neat wiring. It looks good. If it looks good, it will fly good. No. I've cut the wires to the right length on the receiver, and I've stripped and tinned the ends. 4 wires, so you've got power, ground, so you've got your positive and negative, and an RX and TX. We can see we've got 5 volts, ground, RX and TX, and those are those 4 connectors there. So let's tin them up. I don't use the holes because I don't changing wires that have been put through holes is an absolute pain. So there. So we'll just tin up these 4 connectors. 1, 2, 3, and number 4. And that's the button that puts it into boot mode if you need to do that. Very, very rarely you have to do that these days, but it's there if you need it. So since I'm going to have the RX here, the receiver here, I'm going to bring the wires in across and then around. So we've got 5 volts is this one and ground is this one, so we'll just do them. So power, 5 volts. Again, I'll use my trusty tweezers to get in there, because compared to these wires, any finger is fat. So 5 volts. It really doesn't take, oops, I moved. It doesn't take much more than a dab on these connections and these wires to connect. That's literally it. EP1 is ground, power, TX and RX. So on this one, TX is green, so that's got to go to RX, transmit to receive. And RX is the next one, so that's great, that's in order. TX. Oh yes. Try and get a nice reliable joint, and RX. Still not happy with that green one. It's all to one side, I like them in the middle. will do. Yep. Okay. And that completes all the soldering I'm going to do on this quad. Pretty much, yeah, it does. And I always twist wires. I always try and twist my wires. And the reason for that is, if you've got any wiring with signals on, like RX and TX, then to have your ground wire and your power wire wrapped around them actually acts like a little screen for it. So it helps cut down the interference. And this metal part on top of the video transmitter will quite happily is a shield in itself, so it's connected to ground. And the final thing is connect this aerial. So what you do to that, and I'll zoom in on this so you can see, hopefully see anyway. Right. You undo this screw, loosen it up, and then you should be able to pull this out. It swivels out. It's got a little catch underneath. So if you push it down, let me look in a bit closer. There we go. I'll undo that a bit more actually. I think this one is making it a bit tight. I think I've got it so well bolted down, this case. Let's loosen that up a little bit. Right, okay. Let's see if you can see it. It's really small. There it is. So this is the connector, and you can see that the one is the mirror image of the other. Nope, I can't go any closer. It's as close as the camera will focus. So these don't take many push togethers before they break. So the thing is to get it positioned right over the top. And I find fingers tend to be a bit too squishy. So I tend to use a large driver, something that will produce a wide area. If I look at that, it's about the same width as that. So I'm just going to push that over, apply that to top, and when you press it should go click. There we go, that clicks into place. That's a good connection. And then we've just got to slide this over the top, and see the hole there, that goes down, and there's a little stud on the underside of this heatsink to connect that to. So we push it down and under best we can. You have to be careful there because there are some components you could damage if you're not careful. And after a lot of work you can see that's in place, and it's quite secure. And now it's just tidying up and buttoning up. I'm going to put some sticky double-sided VHB tape there, stick that on there, put on the rear with the TPUs, and I'll come back with it all done. And that's the completed quad. You can see I've put the antenna with its little rubbers that I spoke to about for the receiver, and it's nicely protected. We've got the transmitter antenna there, and that's in that. What I'm going to do is put a little cable tie around that just to lock that in. I've put the sticky back fabric around there just to neaten things up. And at the front we've got the mount for the HD cam if I want to put one on. And this is the battery pack had they supply. Now I have put a multimeter through the battery connection. There's no dead short that I can see. I can see the current sensing resistor, and I can see the capacitor. You can see it affects, it makes like the resistance go up and then down a bit. But I haven't yet, and this is live on camera, I haven't yet put any sort of battery to it. Should we do that? It's got to be done sometime. I've gone through this with a fine-tooth comb, make certain every positive is going to positive, every negative going to negative. I've scoped out the battery connector. There's no dead short there that I can see. The only thing to do now, and to say it's going to work, notice no pops on, is now I've got a 4S. This is designed for 6S, but 4S will be enough to test it. This is that moment, you know, you go right through it in your head and you think, I've done all the checks, everything's right. I've doubled and triple checked everything. There's no shorts. Do I connect it? Here it goes. Watch out for the magic smoke. Wow! That's all the correct noise. We have a working quad.